Hello, can you hear me? Hello, Virendra, can you hear me? Okay, so we can wait for 5 minutes. Let others to join, then we can start. Okay, we can wait for 5 minutes. Good morning, Arnav. We can start in 5 minutes. Let others to join, then we can start. Okay. Okay. So in today class we will see what topics we have covered, and today is the revision class. Okay. So just we will conclude that what topics we have covered throughout the semester, and on which topic in the machine learning we have to focus on that. Okay. So when we come with the machine learning part, we have seen what is machine learning, definition of machine learning. Then we have seen the types of machine learning. Can anyone tell what are the different types of machine learning? Anyone who can tell? They are mainly, when we see, there are three types is there. First one, that is the supervised. Then another one is unsupervised, and last one is the reinforcement learning. Okay. Whenever we are talking about the supervised learning, means what? Input and output is mapped. We know the output. Just we have to find the function between, what is the function for the y. Okay. That is the supervised learning. When we talk about the unsupervised learning, means what? Our We don't know the target value. Target value is unknown. Okay. Means labeled. Labeled data is unknown. We are not aware of labeled data. Okay. This is the unsupervised learning part. Whereas when we talk about the reinforcement learning, what is reinforcement learning? Can anyone tell what is reinforcement learning? That is the decision based. Decision based. Okay. There will be what? There will be agent to interact with the environment. With the environment. Like we can see, there is the chess. Chess is there. Chess is the best example of reinforcement learning. Okay. So these are the different types of the machine learning part. So now we will come to the supervised. First of all, supervised. 1 minute, let me save this. I think today's class, today is, I think, 6. So this is slide 1. So in the supervised learning, we have seen what are the different techniques we have seen in supervised learning. Anyone who can tell what are the different techniques in supervised learning? In supervised learning, what are the different techniques we have studied that? Anyone who can say that? We have studied the two techniques. One is the classification, and another one is the regression. Okay. So in the classification, that is, when we talk about the classification, what do you mean by classification? It should be a what? Categorical data. Okay. Means it should be in yes or no. Okay. So it should be in categorical data. Then when we are talking about the regression, it should be a continuous data. Okay. This is the main difference between classification and regression. In the classification, what are the different techniques we have studied? That is the KNN. Then we have studied Naya Bayes. Then we have seen the decision tree. Then we have seen the SVM. These are the four techniques we have studied in the classification problem. When we talk about the regression problem, we have studied about what? That is the linear regression. Linear regression. Then we have studied about the next one. Next part is that multiple regression. Then we have seen the polynomial regression, and last one we have seen the logistic regression, which is a part of classification only. Okay, so these things we have studied about in the supervised learning. Okay, now we will see about the KNN part. So in the KNN part, what we have seen, what is the algorithm for the KNN? Can anyone tell? What is the algorithm for the KNN? KNN के लिए क्या क्या algorithm है? क्या steps है? Anyone who can say? No one knows. What are the steps in KNN? Arnav, can you tell that? That is supervised, but I asked the steps. So first step is the distance. We have to calculate the distance formula. The distance can be Euclidean, Manhattan, whatever it is. Then what we have done, we are doing the sorting part, sorting. And third one is that is the majority vote. Majority vote. According on based on this, we can do the KNN part. Okay. For the K, what is the K? K is the number of distance calculate for the majority vote. Okay, this is K. So K will be always odd, not take even. Okay, now come to the next part, that is the uh, next what we have studied, that is the naive Bayes. So when we talk about the naive Bayes, what is that? Naive Bayes is the probabilistic machine learning algorithm based on Bayes theorem. Okay, it is mainly used for the classification. Why it is called naive? Can anyone tell why it is called naive? Because it assumes all features are independent of each other. Which is really true in real world. Okay, you can really find a feature which is not depend upon other. Okay, so there will be the independent part. So all the it assumes that all features are independent of each other. Okay, now What is the formula for the bias theorem? Can anyone tell? What is the formula for the bias theorem? Anyone? So bias theorem is that when we talk about the bias theorem, it is P of Cx is equal to P of Xc into probability of C by probability of X. Okay. So when we talk about P of C of X, it is what? It is posterior probability of class C given features X. And what is P of X C? It is likelihood of features X given C. What is PC? That is prior probability of class C. And what is Px? It is the probability of the feature. So naive Bayes work on this only. Okay, very clear with this. So whenever we are talking about, so if we have a set of feature x is equal to x1, x2, x3, dash xn, then naive Bayes assume that P of x and c is equal to P of x1 class C given class C into probability of x2 given class C dash P xn class given this. Now, can anyone tell what is the types of naive Bayes? Can anyone tell that? First one is the Gaussian. That is the Gaussian naive Bayes. Assume continuous and normal distribution. It is continuous and normal distribution. Now, what is the next part? That is the next type of naive Bayes. That is multinomial naive Bayes it is used for discrete count. Example, can anyone tell the example? Word count in text. Word count in text. And third is what? Bernoulli naive Bayes. That is binary and Boolean features. That is the word presence in text What are the example? Uh, what are the applications? Can anyone tell? Applications, that is the spam detection, the best application. Then sentiment analysis. Then we have the document classification. These are the medical diagnosis. These are the best example of database. Okay. Now next part. That next part is what? That is the decision tree. Okay. So we are coming to the decision tree part. Decision tree. So it is what? It is used for the both. It is used for the classification also. It is used for the regression task also. So it is used for both classification as well as regression. What it mainly do? It split the data into branches. Okay, it split the data into branches based on their features. So it has a tree-like structure. Okay, so what are the basic structure of the decision tree? Can anyone tell? That is the root node. This is the root node. Root node is what? What do you mean by root node? The first node that split the data set. Then another one that is the decision decision node. Decision node. This is also known as internal node. Internal node. So what is the internal node? That is split on the conditions. These are the internal nodes. They split based on the decision. And third one, that is the leaf node. That is the final output. Final output. That is a class or value. These are the leaf nodes. And next, that is the branches. So what is the branches? It is the path from the root to the leaf node. This is the path. So how we can do that in the decision tree? So in the decision tree, best feature selection, best features to split, best features to split. There are the two criteria. First one is the Gini index, Gini impurity, and second one is the entropy. Entropy, that is the information gain. Information gain. And this whole process, the splitting of data, is the recursive process. Okay. So we have to calculate the information gain, then IG S comma A, that is the entropy of S minus summation of V value, that is A, and SV by S entropy of SV. So it is the entropy. Whenever we are talking about the information gain, it is the entropy of the parent, average weighted, and entropy of the child. This is the based on the entropy. And Gini index, that is the, whenever we are talking about the Gini index, it is 1 minus summation I is equal to 1 to C pi square. This is the Gini index base. Okay. What are the advantages of the decision tree? What are the advantages and disadvantages of the decision tree? So when we are coming to the advantage, what is the advantage? Easy to understand. Second one, handle both, that is the classification and regression. Okay. Whenever we are talking about the classification, means what? It is a categorical data. Categorical data. What is that? Is yes, no, true, false. These are the categorical data. Whenever we are talking about the regression, it is what? It is a numerical data. Numerical data, that is a continuous. Third advantage, little processing. It requires little processing. Now, what are the disadvantages? Can anyone tell what are the disadvantages? Hmm? First one, unstable, unstable to small changes. Second one, not perform well, not perform well with imbalanced data. And third one, that is prone to overfitting. These are the disadvantages of the decision tree. Okay, any doubt is there? Anyone? Any doubt? Now next we can come to the SVM part. So when we are talking about the SVM, that is support vector machine. What is that? It is a supervised learning used for both. It is also used for classification and regression. Remember it. But when we talk about, mainly it is a powerful for classification, binary classification, sorry, for the binary classification, and work well in higher dimension. In higher dimensional space. Okay. Now, what is the aim of the SVM? SVM aim to find the optimal hyperplane. Optimal hyperplane that separate data point of different classes with maximum margin. Okay, so this is the main goal of SVM. SVM that it finds the optimal hyperplane that separate the data point of different class with maximum margin. Whenever we are talking about 2D, means that it is a line. Whenever we are talking about 3D, it is a plane. And whenever we are talking about higher dimension, then it is a hyperplane. Okay, these are the important things in SVM. Now, some of the technical terms are also in SVM. First technical term is support vector. Support vector. Can anyone tell what is support vector? Support vectors are data points close to the hyperplane, closest to the hyperplane. They define what? They define the margin. What is margin? Can anyone tell what is margin? It is the distance between the hyperplane and nearest nearest support vector. So SVM maximizes this. Can anyone write the hyperplane equation? Hyperplane equation. Can anyone write it? That is WT transpose x plus b is equal to 0. Okay. Now types of SVM. What are different types of SVM? Types of SVM. First one, that is the linear SVM. When it is used, when data points are linearly separable. Another one is non-linear SVM. In this we uses kernels to map data to higher dimension. Okay, these are the two types of SVM. Now, what are the common kernel function? That you should know that. Whenever we are talking about the linear, that is k, x and x dash. Then it will be x transpose into x dash. Whenever we are talking about the polynomial, that is k, x, comma x dash, it will be x transpose x dash plus c, and that is the power of d. Okay. Now, what are the advantages? Can anyone tell what are the advantages of SVM? Advantages. First of all, it is effective in higher dimension. Always remember, it is too effective in higher dimension. Okay. Work well with clear margin of separation. And the most important advantage is memory efficient. Memory efficient. What are the disadvantages? Can anyone tell what are the disadvantages of SVM? One of the most important disadvantages is that not suitable for large data set. Not suitable for larger data set. Now another one, choice of kernel. Choice of kernel and tuning parameter. Tuning parameter are, are critical. And the next one, less effective when classes overlap. Okay, are you clear with this? So these are the best example of supervised learning, and these are the classification. Okay, now next one, that is the regression part. We can come to the regression part. So in the regression, I already told you, is a type of supervised learning where the goal is to predict a continuous output based on one or more input features. Okay, so what are the common types of common type? That is the type of regression. The first type is linear regression. Then second type we have the multiple regression. Third type we have the polynomial regression. Polynomial regression. Then fourth type we have the rigid and lasso regression. Then we have the fifth type, we have the logistic. logistic regression. Then we have the SVR, support vector regression. It is the extension version of SVM. It is a support vector regression. And seventh one, can anyone tell what is the seventh one? That is the decision tree and random forest regression. That is tree-based model that handle the non-linear relationship. Okay, everyone, are you clear with this? Regression and different types of regression. Then we have the evaluation parameters. Evaluation matrices. What are the evaluation matrices of regression? That is MSE, mean square error, MAE, mean absolute error, then R square, and then we have adjusted R2. These are the regression matrix, evaluation matrix of the regression. What are the applications? What are the applications of the regression? That is a prediction of house price, forecasting the weather, stock prices. These are all the example of the regression. Okay, everyone, clear with this? कोई डाउट है किसी को? Now, what are the we are coming to the next part, that is what are the evaluation matrix of the classification problem. Tell me. What are the classification problem evaluation matrix of classification problem? Can anyone tell? No one. I already discussed in the class, that is the confusion matrix. For the classification, evaluation matrix, evaluation matrix, matrices, sorry, matrices are confusion matrix. What is the table of the confusion matrix? This is predicted, prediction, this is actual. So it is actual positive and actual negative. It is productive positive, it is productive negative. So it is what? If this is true positive, this is false negative, this is false positive, and it is true negative. Okay. Now what is the formula for accuracy? Accuracy will be this by whole. So it is Tp by Fn by Tp plus Fn plus Fp plus Pn. Okay. Now what is precision? What do you mean by precision? It tells that how many predicted positives are actually positive. Means कितना positive actually में positive था. So it is what? It is TP by TP plus FP, all positive values. So precision tells how many predicted positives are actually positive. Now what is recall? Recall is that how many actual positives are correctly identified. Okay, how many actual positives are correctly identified. So it is recall. Recall is equal to TP by TP plus FM. See, don't get confused with this. Precision and recall. Precision tells how many predicted positives are actually positive. And recall is telling how many actual positives are correctly identified. Now come to the F1 score. F1 score is the harmonic mean of precision and recall. So it is 2 into P into recall, precision by recall, P plus R. Okay. Another one is the T, that is the true negative rate. That is the specificity. That is the Pn by Tn plus Fp. Tn by Tn plus Fp. That is the true positive rate. Okay. Everyone. So just on the drive, I will upload whatever I've taught till now. Just revise it. I am giving you 10 minutes to revise that. Then after that, we're gonna start with the uh, unsupervised learning part. Okay. Today is what? May. That is the 6th one. So in the drive, when you go, you can find the 6th May material in this whatever we have revised towards the supervised learning, that all are present here. Just to go through that. After that, we will after 10 minutes revise it. After 10 minutes, if you have any doubt in supervised learning, you can ask. Else after 10 minutes, we will start with the unsupervised part. Okay, just go through these all slides, which is already uploaded in the drive. I am giving you 10 minutes to go through this. So we have completed the supervised learning. So now we are coming to the next part, that is the unsupervised learning. So I already told you in the unsupervised learning what we have seen. We tell that we are not aware of the uh, what that is the level data. Okay. So then how to handle that type of problem if we don't know the so uh, the key concept of the unsupervised learning, that is no level data, unsupervised. So no level. Okay. So what are the techniques we use in this? Techniques we are using, that is the clustering. Then another one we have the dimensionality reduction. Dimensionality reduction. Other rules are also there, that is the associative association rule learning, and another one is the anomaly detection. Anomaly detection. Okay. But here we have to focus on the two things, that is the clustering and another one is the reduction. Okay. So we are coming to the next part, that is the clustering part. So when we talk about the clustering, so in the clustering we have the clustering is the unsupervised learning, that is the unsupervised. Used to group a similar data point together based on the similarity measure. Okay, so it group it similar data, and what is the based on distance or similarity. In machine learning, when we talk about similarity, we are only telling about the distance. Okay, so what are the key characteristics? What are the characteristics of clustering? First one, no predefined level. No predefined level. Second one, what is the second one? Each clusters contain the data points which are similar to each other. Similar to each other. When we are talking about similar to each other, means what distance will be less. Okay. What are the common clustering algorithm? Can anyone tell? What are the common clustering algorithms? First of all, that is a k-mean clustering. K-mean clustering. What do you mean by k-mean clustering? What are the steps in that? Partition the data into k clusters. Uses the centroid to define the clusters. Then sample. Then then we have to apply the specify the k. These are the three steps. that is the partition data into K cluster, then use centroid to define the clusters, and then specify the K. Then another one, what is that? That is the hierarchical clustering. So in the hierarchical clustering, build a tree of cluster which is known as dendroid, dendrogram, dendrogram. It does not require any pre-specific number of clusters, and it has the two types, that is what? Agglomerative, that is bottom up, and divisive. In the hierarchical, we have the two types. When we talk about the hierarchical clustering, we have the two types. One is the agglomerative, that is bottom up, and another one is the divisive, that is what? That is top down. In this only we can come with the, that is the graph based model. Okay. Another one is the DBS scan, that is the density based spatial clustering of application with noise. Okay, this is what? This is density based spatial clustering of application with noise. So what it is telling, it is group together the point that are closed, and it is good for identifying the outlier, that is the noise, and cluster with the arbitrary shapes. Next part, that is GMM, that is Gaussian mixture model. It is based on the probability distribution. Okay. So where the clustering algorithm will be used? What are the real world example? That is the customer segmentation applications. When we talk about the applications, it is customer segmentation, document categorization, document categorization. Then we have the image segmentation, and fourth one, that is the anomaly detection. These are the application of the clustering. Next we have what we have, that is the uh, dimensionality reduction. Dimensionality reduction. In this we have seen the PCA, that is the principal component analysis. We have seen this. In this, what we have seen that how higher dimension is converted into lower dimension. Higher dimension is converted into lower dimension. That is how, first of all, we have to calculate the covariance matrix. Then we have to calculate the eigenvalues and eigenvectors. Then what we have to calculate? Can anyone tell? Anyone who can tell what we have to calculate it? Then we have to calculate the PC, principal component 1, 2, the points. Eigenvector we have already calculated. Okay. After that, we have a study about the model. Yes. Then after that, we have a study about the Markov model. Markov model. In the Markov model, we have seen the three things, that is the Markov property. Then we have seen the Markov property, Markov rule, and Markov chain. So we can the Markov we can say that the future state only depends upon present state, current state. It has nothing to do with the future state. So probability of transition, this is a transition. So P of xt plus 1 depends upon xt only. So this is a Markov model. In this only we have seen about the hidden Markov model, that is the latent variable, like 18, 19. That is the hidden Markov model. So this is what, this is one layer. So these are known as hidden layers. Okay, these are known as observable state, and we have the initial. Okay, so we have, based on the observed state, we have to find the hidden layers. Okay, we have seen the probability, that is the this one is the, these are known as transition matrix, and this is known as emission matrix. Okay, are you clear with this? So these we have seen a numerical also on this. So how to calculate the if this is sunny, this is sunny, this is sunny, rainy and cloudy. So what will be the what will be the combination of that? So everything we have seen that we have to calculate the probability, and based on that we have created that. Now what is the problem with the hidden Markov model? Can anyone tell? What are the problem with the hidden Markov model? So we have seen the two things. that is the evaluation problem. And second one, we have seen the decoding problem. So that is the decoding problem. We have seen the, what is that? Another one more problem is that is the learning problem. So in this we have seen the Varvi algorithm, Viterbi algorithm, and in this evaluation we have seen the forward and backward algorithm we have seen. Okay, so these things we have already, we have all, everything we have covered throughout the semester. Okay, till here any doubt is there, you can ask. We have seen also one thing, that is the, what you are asking. See, that depends, Manu, that depends upon the applications. Like in the Minkowski, if we take h is equal to 2, then it become what? It act as a Euclidean. Okay. Assume not, we have to select it. Okay. And when we talk h is equal to 1, then what is that? When we are taking h is equal to 1, that is the Manhattan. So according to the application we have to take. Okay. We have to also see the another thing, that is the computational capacity of the system also. Okay. If you want, you can distance uh, distance. We have to understand the data part. Like I'm telling you one thing. Wait a minute. I'm just explaining that. Let us take one example, that if the dimensions are sparse, or we can say it is in the higher dimension. Higher dimension. So it is better to take h is equal to 1. That is the Manhattan, because it performs well. Whereas when the data, whenever we are talking about the dense and normalized data, dense and normalized normalized data, then you can take h is equal to 2. That is the Euclidean distance. Okay. So based on that, we have to see based on the applications. If our data, if the dimension are sparse and in the higher dimension, it is better to take Manhattan. If it is dense or normalized data, we have to take the Euclidean, h is equal to 2. Or we can also try with the hyperparameter tuning. Hyperparameter parameter tuning. That is the cross validation. Means cross validation with what? Compare the cluster performance on the on different value of h. That is also known as grid search. मीन्स हम क्या करेंगे, एच की डिफरेंट वैल्यू लेंगे, उस पर हम चेक करेंगे कि मेरा क्लस्टर का परफॉर्मेंस कैसा है. लाइक पी बाई लाइक एच इज इक्वल टू 1, एच इज इक्वल टू 1.5, एच इज इक्वल टू 2, एच इज इक्वल टू 3. ओके. और उसके बेसिस पे हम लोग क्या करेंगे, क्लस्टर का परफॉर्मेंस निकालेंगे. तो क्लस्टर का मैट्रिक्स क्या होता है? कैन एनीवन टेल क्लस्टरिंग मैट्रिक्स? that is the Salhot matrices, Salhot score. And if you have if you have the domain knowledge, then we can say that if the data set is small, if the a small difference, then higher p might specify the better difference. Okay, Manu, are you clear with this? So that is all based on the application. That's why we can see before applying any algorithm, we are doing the processing of data. Processing of data means that we are analyzing the data. Which type of data is that? It is the balance or imbalance. So everything we have to see. Then only we can apply the algorithm. Okay. Anyone has any more doubt? So with this, we have completed the syllabus of machine learning part. Okay. When we talk about the reinforcement learning, it is another subject. Okay. जब हम reinforcement learning की बात करें तो वो एक other subject है. But in the machine learning, there is a two thing, that is a supervised and unsupervised. Okay. Any more doubts you have? Anyone? Any confusion? I think with deep learning in the next semester. So if you understand the machine learning, then only you can understand the deep learning. So during the vacation time, you can try to get master in machine learning part. Okay. Okay. Thank you. I am stopping the recording part. Okay. Thank you to all. If you have any doubt, you're free to ask anything anytime. Okay. Just keep on practicing and do the Python code to implement it.